Hello, this is Nathan Torno, again on the StatCrunch development team, and this should be the final KT session, knowledge transfer session for the Applets menu. So what we're going to do is, again, the StatCrunch Applets menu is what we're hitting. Before in the previous sessions, we hit Bayes rule all the way through random numbers. So what we're going to do is going to hit these last few items and just discuss what needs to be known, especially on the side of QA. So to begin, we're going to do regression by eye. Regression by eye and regression influence are very similar to each other, very close cousins to each other as far as the code behind the scenes and just how they function. So we're only going to cover one of the two of these. But if you can handle one, you should be able to handle both. Likewise, regression by eye is very similar to both mean versus median, this one right here, this applet, along with correlation by eye. Pretty much the same kind of concept overall of like what's happening programmatically is there, just a different use case. So again, regression by eye is what I clicked on here. And again, we have the option to either use randomly generated data or from the data table. So for this one, we'll just leave the defaults. Again, all other options need to be tested at some point because they do bring another aspect to it, like the from data table or adding boxes. I'm going to go ahead and click randomly generated. So this will be very similar in look initially to the correlation by eye applet. So very similar. It's the same kind of canvas behind the scenes. So as a programmer, it's the same canvas handling both. And just like the correlation by eye, this one has the ability, if you click on a point, it'll add a point. If I grab a point by clicking and dragging, I can move a point around. So again, the exact same functionality. If I drop a point outside of the range, it's going to delete it for me. So again, it's very similar to correlation by eye. For this one, what's unique about it is it specifically deals with regression. So you can turn these lines on and off. So this would be the true regression line. This is what the user decides is their best guess. So if I'm a user, I can drag these points and try to guess at where the true regression line should be for this linear regression. I can compare that to the red line, which is the least squares regression line. Overall for texting, again, for all these, you want to resize these, so it needs to resize appropriately. Again, that's working. You check copy. Make sure it's creating a copy of it appropriately. For this one, you need to be able to move points. If I simulate new data sets, it needs to handle it appropriately. Be able to turn these lines on and off. That should work. If I simulate, let's say 5 points instead, I'm only going to get 5 on the graph, and you're seeing that correctly there. So just a lot of these interactivity elements like this, moving this thing around, just making sure it doesn't go off screen. This red or this green line. Simulation, you can add points also. So in this case, if I'm going to add a point, I can potentially add a point off screen. So let's say I want to add a point, add 0. Let's say 0, 0. But x equals 0 and y equals 0, I'm going to add a point. You'll see that pop up down there. So it can potentially expand that range. Basically, if you're used to correlation by eye, you should be able to handle this one very similar. And likewise, regression by influence is very, very similar to this one over here. So really, regression by eye, regression influence, correlation by eye, and then also to a lesser degree, mean median. They're very close cousins to each other. Mean / SD versus median IQR. Okay, so that's regression by eye. Again, I'm going to not spend too much time there just because it's very similar to one we've already seen. Next one for testing, regression simulation. So again, regression influence, very similar to by eye. So regression simulation. So this is something that uses fixed versus dynamic seeding. Anytime there's randomly simulated data for these applets, it uses fixed versus dynamic. You can use from the data table, or you can use fixed values across a range. So again, I'm just going to click on the default for this case, and we'll just see what this applet does. So what this is going to do is, if I click one time for this, it's going to simulate 10 values, x and y values. From those 10 values, it's going to find the slope and the y-intercept for a regression equation. So again, simulates 10 values, finds the slope and the y-intercept. And from there, it's going to drop it onto the graph. So in this case, there's a slope of 1.0717, and you see it on the graph at 1.017. So the same kind of format in general. So if you see these numbers up here, 1 time, 5 times, 1,000 times, that's very consistent within simulation-based applets. Do 5 times, it's going to again simulate. Each time it's going to simulate a data set of size 10, 10x values, 10y values. It's going to find a regression equation, and it's going to drop it onto the graph. So we see the second one right here. It's at 1.029 is the slope. You can see the x and y values that were randomly simulated for this. And it was dropped onto the graph over here. If I click 1,000 times, it's going to quickly add information to the graph. So again, just simulating each time, it's simulating a sample of size 10, x and y values, and then it's going to find the regression equation for it. Same interactivity applies for these graphs. So I can click on these numbers over here, and I'll be able to find any individual simulated data set. I can also click and drag. So if I want to find this outlier over here, there's 2 runs that qualified. I'll just go with the first one and click View. And so I clicked that around 0.08, 0.8. In this case, 0.8 is the slope for this one. So you can see that matches up with what we should expect. Likewise for this graph, again, you have inflow and reset. Those are consistent throughout. Sample size is consistent throughout. If I click on y-intercept, it just gives you a different graph. So instead of graphing the slopes, it's going to graph the y-intercept. So if I click and drag over here, I found a around 11 should be the y-intercept. And again, right there, we've got a y-intercept almost exactly at 11. So it matches up to what you selected over here. And this list is going to show that run number within the table on the far left. One thing unique for this regression graph is it has these regression lines. So it has 2 different graphs, but then the third graph is unique to this. So what it does is for this, it's going to show in pink the currently selected line. So 1704 is the run we selected. It's going to show that regression line. The blue is the true regression line. So in this case, we're simulating with a slope of 1 and y-intercept of 0. So that's what the true line should be. And all the gray ones are any other regression lines that are graphed. So again, the blue is the default. The pink is the current selected one, and then the brown, gray is for any other line. And this graph's not interactive at all. So if I click and drag, it doesn't do anything in this case. So in this case, you need to be able to simulate any graph. So I can add values to the y-intercept graph, and they'll show up in the slope when I click over. If I add values here, if I click on regression lines, it'll take a second because it's a little harder of a drawing procedure, but it'll show up over here. Reset over here and click 5 times. I'll see 5 lines added to the graph in order. And if I move over, I'll see those pop up in their graphs. So again, resizing needs to work for any of these situations. Copy needs to work. So copy will show the current graph shown. You also have a few options down here. So I have markers. I can add markers to the graph. I've shown this before, I believe. You know, dividers. We talked about that before. Paints. So if I want to draw on this graph, that'll work. Notice though, if I click 1,000 times, it's going to move the paints. I think we've talked about this previously. That is not a bug. That's just something. That's just the way the paint is operating. It's going into fixed X and Y locations. So as the graph changes, it's going to be locked in to the previous locations that we're at. So this one is very similar to the hypothesis testing applets. So very similar look and feel to them. Only difference is really the regression lines, just the type of data that's being done. You'll also see in a second that these are very similar to both resampling and simulation. So there's really hypothesis tests, and these 2, regression simulation, resampling, all 4 of these, and then simulation, all 6 of these. All very similar canvas being done, very similar formats to the whole applet. And they're all simulation based also. Okay, next we're going to hit the resampling applets. These four are pretty similar to each other. They're also similar to the one we just covered. I'll go and just hit one of these. So I'll just do correlation. This one, all four of these require data. So in this case, we want to find the correlation between, let's say if we can find the budget and the domestic row. So that's going to be a pretty high correlation. We want to see if there's possible to find that by random chance. You don't have to fully understand the statistics behind this. But by default, you get a graph that's pretty similar to before. You have a little table to tabulate information from the graph. If you click on data right here, it'll give me the default data set for this. And also give me a regression graph for it. So I get the correlation of my data. If you did a scatter plot, you should get the exact same graph as this, the data behind the scenes. And this is my budgets and my domestic grosses. Again, that are in the behind the scenes in the data table. This number right here is what corresponds to the number that's being tallied on the table. So that should show up correctly. In this case, it is showing up correctly. So again, very similar to the one we just hit. If I click on one time, it's going to randomly simulate or randomly shuffle the data. So it's going to randomly shuffle this domestic column and then create a, find the correlation for that. So in this case, it was a native 0.0156 correlation. You can see that showing that up there on the graph. Click 5 times, again, the same kind of operation happens. Just randomly simulating, randomly shuffling those correlations and putting them on the graph. Click 1,000 times, it's going to do it really quickly. One thing I'm going to change to this, just to make this a little more interesting scenario, I'm just going to make the first 50 rows for this. First 50 rows, you have about a correlation of 0.42, and you can see the data right there for it. So what's interesting about this, if you click one time, you'll actually see that shuffling behavior there. It might be hard for you to see, but what's doing is it's trying to give you an animation of what's happening. It's shuffling this column, randomly assigning it to different values for that column. So if I click on one of these, I'll show that happening. Again, it's shuffling this column, and then it's reassigning the rows accordingly. So it's randomly assigning these values to see if by random chance we can find this correlation. You also see things that are more extreme are going to be highlighted in red. So anything that gets beyond the number established in this table, it's going to highlight in red. It's going to tally those also. A couple things to check for this. So again, resizing, like I just did there, needs to work correctly. You can check all of these different features. Again, we've covered these previously. Options copy needs to work. So it needs to create an image of that correctly. So I can move this and put this anywhere else, and that'll work. Also, for this one, you need to check analyze. So what's going to do is it's going to show those randomized correlations, and you put them in the table. So the data for this graph, we can put in the table and then use it anywhere else. So if I go over here, just for example, if I create a histogram of these, it'll be roughly the same as what you see over there. So different bins, but the same data for this versus this. Again, those from the analyze, I just use the data from the data table. Same interactivity too, so I can click and select on one of these values over here and find an extreme value. So in this case, it's a high correlation. Clicked over there, found a correlation of 0.572. That behavior you're seeing, by the way, that shuffling only happens, I think, when there's less than 200 values. If there's more than 200, it's just too much information to shuffle. So don't expect to see that if the data set's too large. Okay, and pretty much the other resampling applet's very similar as far as a QA standpoint. So if you know how to test one of these, you should maybe know how to test the other ones too. Very close cousins to each other. These guys are also very similar to hypothesis testing and simulation. Some kind of format happening behind the scenes. So there's a similar code base being used, or overall there's the same code base being used with just some modifications. This all brings us to the most complicated applet within StatCrunch, which is the sampling distribution applet. This one's the hardest to test. It's also the hardest to code, just the biggest applet. There's just a lot going on for this one. So we have the various distributions you can use, or you can use from data table. Again, these are slightly different, so you need to test these if you want to confirm this thing is working correctly. You have 1 versus 2 statistics. I'm just going to leave out 1 for this case. I'll just click on the default for this case. So we're going to use a uniform population. The basic idea for this applet, I'm resizing this just slightly. Again, resizing working. You need to test that for any applet. Make sure the resizing works appropriately. What this will do is it's kind of a 3-graph situation where I've got a raw distribution. I can actually draw on this distribution. So if I click and drag, I can change my distribution to be anything I want it to be. So in this case, I just want to make 3 little hills there. Let's just go with that for our distribution. So what's going to happen in this thing, you'll see, first of all, that these statistics, they're in different colors. They're actually corresponding to the things on the graph. So that blue represents the standard deviation. The green arrow represents the mean, and the median arrow gets represented there also. So for this applet, it's one of the most popular applets also. If I click one time, what's going to do is, based on the sample size established over here, it's going to sample that number of values. In this case, it's going to sample 2 values from this population. It's more likely to find values with a high distribution than those with a low distribution. Click one time, it's going to grab 2 of those values. You're going to drop these onto the samples graph, and it's going to take the mean of those 2 values and put them onto the sample means graph. So what you see here is the current sample, each of size 2 in this case. And that mean gets dropped onto this graph right here. So click one time again. It grabs 2 values, found the mean of those, and it dropped it onto this graph right here. So this graph is telling all the sample means. This is just telling the current sample. So click one time again. Grab 2 values from this distribution, this population, and then it dropped the mean onto this other graph. This graph is really the one of interest long term. If I click 5 times, grab 2 means, drop them on the graph. Grab 2 means, or 2 values, drop them on the graph, the mean of them. It's the same repetitive process. So each time I'm grabbing a sample of size 2, and I'm dropping the mean of that sample onto this graph below. If you click 1,000 times, so in this case, I'm up to about 10,000 samples, because I clicked 1,000 10 times. Overall, these are all the means. So I've got 10,000 samples, each of size 2. And this is the distribution of all the different means for that sample, for those samples. So we had means anywhere from 0 all the way up to about 50 over here. Also records the median and the standard deviation, and you see some corresponding arrows. Arrow in this case is yellow because they're pretty much overlapping. If these arrows are farther apart, the mean and median, the one would be green and one would be red. A couple things to check for this. So additional features. So if you click on these plus buttons right here, it'll just give you additional information about the population. So that's the corresponding statistics for this population up here, because I clicked on that plus over here. Likewise, this one's going to be pretty boring, but for 2 values I have, that's some more additional information for them. More interesting down here, these are all the sample means. You have this summary information for them, statistics. The mean is about 24.27. And then you get a QQ plot and some additional information that's relevant for testing normality. So these little 3 checkboxes need to be checked for this. If you change this value right here, it's basically doing the equivalent of reset. So if I just do a sample of size 30 instead, let's say, it's going to reset the whole thing because I have a new sample size. So it'd be the same thing as using the reset button. Click one time, it grabbed 30 values from this graph and then drop the mean onto this mean graph. Do one time again. Again, I sampled 30 values and the mean you see down here. If I click 5 times, you're going to get 5 of those samples, each of size 30. 1,000 times, do this several times. You're going to have 10,000 samples in this case. So these do have this little graphical editor menu you'll see down here. So these bottom 2 graphs, you can add things. So I can add dividers to this. So if I'm interested in my sample data, I can add dividers to it to try to find more information about it. Same thing applies towards the sample means graph down here. There's also this special option that's only within this applet called zoom x-axis. What this is going to do, if I click this on, it's just going to zoom in the axis to the only existing range. So before it was from 0 to 50, now it's zoomed in to where I can just see the data more closely aligned. So as long as this is turned on, it's going to zoom in as close as possible. If I click to fix x-axis, it's going to reset it to be the range from the ones above. So that's something additional that has to be checked. So I do turn on zoom for this guy down here. As I'm adding values, it's going to zoom in and just zoom into the current values. So you'll see the axis range changing because of that. So this is something in particular on these bottom graphs that need to be checked, is the zoomed versus fixed x-axis. You can also add dividers down here. So same kind of thing. I can see what percentage is between 2 different points. So that needs to be working also. A couple of things to point out about this. So again, copy needs to work. So I need to be able to copy and see the information as currently shown. So here in this case, you can see all 3 graphs shown up correctly. Likewise, so a couple other options to check for this that are in particular important. So from data table, it operates a little differently, and also binary is pretty special also. So let me just do from data table real quick. I'll show you this one. I'm also going to add a second value over here just so you can see that you can do multiple graphs at the same time. So this I have a very Rice-Skew distribution. It's the budget in millions that you see behind the scenes there. These values should line up to what you can get by just doing summary stats on the data behind the scenes. What's of note is you can't change the graph at all. So if I click and drag, it's not going to change it. So you lock down to a set data in this case. If I click 1,000 times, these are all the means and these are all the medians. I'm actually do this bigger sample size, for example. So I did, in this case, there's 30. It's the median right here that gets dropped onto this median graph, and the mean right there gets dropped on the mean graph. So if I do this again, that mean got dropped over here and the median got dropped over here. So you can track multiple statistics at the same time. The same thing information otherwise applies to the sample means versus sample medians for this. So this over a long time, you're going to see slightly different distributions. I can zoom these things in so I can get a better look at what these things look like. Lastly for this, what's of importance is these statistics need to be checked really binary versus, or from data table and versus these populations to be checked. And also binary is pretty special. You'll see the statistics down here change a little bit based on this. It's just a slightly different graph. So instead of having a distribution that's you can draw on, what you have is just 2 values. So how many zeros, how many ones, what proportion ones is what you're tracking for this. Everything else works roughly similar, but it's going to be much more discrete in nature because you're dealing with a discrete distribution. So again, just something to check for this. This one takes a lot of time to test appropriately because you're looking at different options. You're looking at 1 versus 2 statistics. you check if the fixed seeding is working like it has in previous applets. And there's just a lot of interactivity within the actual applet. You have 3 different graphs for each applet that are working in unison. Okay, that was sampling distributions again. That's probably, that is the most complicated applet within StatCrunch. So something to work on or to look into. It's also one of the most used applets within StatCrunch. Okay, so just got 2 more I'm going to hit because simulation applets, they're very similar to each other. So I'm just going to show you one of these. Very similar to something you've already seen too. So we'll move that quickly and then we'll do a spinner and we'll be done. StatCrunch, this is actually a separate feature that we'll probably talk about in the future. It's something that's more of a resource within StatCrunch, but we just linked you down here. So simulation, in this case, I'll do for, let's just do for dice rolling. So there's different information. You can keep track of the average of dice rolls or the sum of dice rolls. In this case, let me say I'm going to roll 2 dice with 6 sides total, and I'm just going to do the sum of those. So what's going to happen, you have this event table that keeps track of it. This is true for all the simulation applets. You have this specialized event table for what you want to keep track of. So in this case, I'm keeping the sum of the rolls. Let me just hit 1 run here. So what happened is I rolled 2 dice. You can see the dice images there. These dice images will only show up if it's a dice that is, I think, a 6-sided dice, I believe. In this case, there's a total of 7. You see the 7 got knocked onto the graph or dropped onto the graph as a result. Click 1 run again. Total equals 6, so 2 plus 4 equals 6, and you'll see 6 get dropped onto the graph down there. Do this again, 3, 3, so 6, and you'll see a 6 get dropped on the graph likewise. Click 5 times, I'll just drop 5 rolls. Again, I'm rolling 2 dice. Those 5 rolls will get rolled onto the graph. So the sum of those 5 rolls, sum of those 2 rolls apiece 5 times. That's what's happening there. So again, similar kind of simulation environment we've seen in other applets. If I look 1,000 times, again, I'm just rolling 2 dice each, 1,000 times, and then dropping the sum of those onto the graph each time I'm doing that. Same kind of interactivity as far as the graph's concerned. I can click and drag. I can find, a roll of just 2 ones. So in this case, there are several situations where I rolled double 1. So if I just go to roll number 99, you'll see that I got 1 and 1. So those should line up with what you're seeing on the graph. Likewise, if you click over here, if I click on 134, I can find what happened at run 134. What's different about these is that they have this little criteria that you can change. So I can say whatever I want to find. So let's say I just want to find all rolls of 7. So I can see that total there's 634 times where 7 was rolled. I do that for any number here too. So let's say I just want to know the number times 2 is rolled. In this case, I have 144 times where there's a total of 2 or sum of 2 dice. So just 1 and 1 in this case. So what this convergence graph is doing is just over time, what's the proportion of the rolls that met that criteria? So if I say the proportion that's, let's say just greater than 6. So over time, this shows you after each run what proportion of the total was greater than or equal to 6 or greater than 6. Let me go and reset this just to give a better idea what's happening here. So if I do click on 1,